Hello again. Before we get started, I would like to say thank you for the likes, comments, and subscriptions. If you enjoy this content, please go ahead and hit subscribe once again. Otherwise, we'll get started. In our last video, we were talking about Linux repos. What is a repo? A repo is a storage location that holds all the different Linux packages we want to download. Often when we download and install Linux packages, it pulls from public repos. That being said, did you know you can host your own repo? I mentioned this briefly a few videos ago. If you recall, a repo is basically just a website. In this case, it is a couple things. It's a website with a URL, and it's also somewhat of an FTP server that holds packages, the dependencies for those packages, as well as metadata about that packages, like what version it is and what dependencies it needs for it to run. Let's go ahead and get started. In our last video, we talked about what a repo is. It would be nice if we knew how to host them. Well, we're going to talk about that in this video. Before we get to that though, we have to talk about your repo configuration file and how that is set up, because that's a pretty important part of hosting your repo. The nice thing about Linux is if you want to change a setting or you want to change a configuration, there's a file for that, right? I really like that there's a file for everything, and you can just go in and play with that file and change the results. It is a very convenient way to manage systems compared to Microsoft Windows. It's not that Microsoft Windows is inherently bad, it's just Linux is a little bit easier for my brain to understand. And I'm making these videos for people who have similar brain structures to me. Acoustics unite! Where are your repo files stored? Well, there's a folder for that. That folder is yum.repos.d. Inside of that folder is a list of different repository files. Let's list some of them. And as you can see, we have a bunch of different ones. Now let's look at the contents of one of these repo files, and appstream.repo. No doubt this giant string of text is rather confusing. Honestly, it confused me too until I read through the book a few times. Let's break down what the different portions of this are. So this is the label for your repo source. If we look inside of this file, you'll see we have a couple different labels. Each one of these represents its own repo. So one file can contain multiple repos, and you can have multiple repo files inside of one repo folder. The next portion of that file is the repo name. Again, this is just what we call the repo. It doesn't have to be one specific thing. You can call it whatever you want. After that, we have the repo base URL, which is right here. And it works just like your normal web server. You would point it to a web-based repo. And last but not least is your GPG key, which is used to verify the security and authenticity of your repo. This makes sure that some hacker hasn't set up a repo and is man-in-the-middling the software you're installing on your server. This is very important, boys. In the ancient days, all the way back in RHEL 6, you would have to write this config file yourself. Nowadays, don't bother with it. There is a utility for that. That utility is called DNF Config Manager. Let's walk through using that application real quick. We last left off talking about GPG keys. What are GPG keys and how do they work? GPG stands for GNU Privacy Guard. Basically, it's an open source implementation of a private public key pair system. It can be used to encrypt communications, applications, and a bunch of other stuff. It is a very powerful encryption tool, and it is used heavily on different Linux systems and for various reasons. How is this information relevant to Linux repositories? Well, GPG keys are used to sign applications on public repos. So basically, when you set up a public repo, you have your GPG key, and you use that key to sign your applications. What happens is, if someone, a hacker for instance, were to try to upload a file to your repo, the keys would not match, or it wouldn't have a key at all. And during the check process of installing an application on Linux hosts, it would see the key mismatch and it wouldn't allow you to install that app. I've actually run into this issue a few times on Debian systems. Another way to manage GPG keys is using the RPM command. If we were to do RPM-K/IOTop, you'll see it shows us digest signature is okay. So this one has a valid key, and that key matches the key that we have inside of the config file for wherever it's pulling this RPM from. Why host your own repo when there's a bunch of freely available ones on the internet? Well, first things first, it allows you to have control over what packages are on the repo, because sometimes public repos do get compromised. Secondly, it saves you bandwidth because you already have the applications downloaded to the local side of your network, so they can be freely deployed to local resources a little bit easier. So how do you create a local repo? There's a command for that actually. That command is dnf config manager. Let's dive deep into dnf config manager real quick. While I was away, I went ahead and created a local repo. I have a folder called repo, and inside of that folder is the basic folder structure for a repository. So we can do ls repo base os, and you'll see we have a packages and a repo data folder. Those are the two folders you're going to need to create the skeleton of a repo. Now that we have the skeleton of our repo created, we can go ahead and use the dnf config manager utility to define our very first repo. Let's go ahead and do that. The command itself is pretty straightforward. It is dnf config manager add repo equals file repo / base os. I forgot a D in there. So let's go back real quick and add that extra letter. And there we go. And with that, we've just defined a repo. Now, if we do ls/etc yum.repos.d, we should have a new repo file, and it's right here called repo-base.repo. But we're not quite done yet. We still have to edit that repo, and we have to change one flag. We have to change GPG check to 0, otherwise this repo won't work. GPG check set to 0 basically means we are not looking for a security key, which is fine because this is a local repo, i.e. it's a repo that is installed and configured on this local computer. Yeah, repos.d and then repo, cool. And you'll see here, it basically just went ahead and defined all our settings to define the name, the base URL. It also enabled the repo, but it still won't work until we set one last flag, which is GPG check equals 0. Cool. And with that, we have now defined a repo. Let's see if we can update from there. If everything worked right, we should be able to run dnf update with no issues. So let's do dnf update and let's see why. And if we had a broken repository, it would throw us a bunch of errors when we tried to update this host. Let's see why. It's doing something. All right, we're at 16 of 206, so this is probably gonna take a while. We'll come back in a few minutes. And it looks like it's almost done. That took a little bit there. And perhaps I need to upgrade the specs on this VM. And we are done. Look at that, boys. The update completed successfully, which means that repo was configured successfully. And that's how you configure a local repo.